morning, everyone. It's 9 o'clock, so we're going to go ahead and get started. I'm Fran Huntoon. I'm one of the folks who does stuff, educators who does work for the All Learners Network, and I'm going to get us started. First of all, welcome. We have, it looks like educators from across the state of Vermont, as well as we have at least one maniac with us, and probably folks from New Hampshire and other states as well. So welcome, we're glad to have you here. All Learners Network is a grassroots organization that started here in Vermont that really works to provide tools for math educators, inclusion for all students, and equity for communities. We're about to jump into our keynote today for the conference. I hope you've all had a chance to check out the sessions, and we'll be able to join us later today for some of the sessions. I know a bunch of the presenters are here currently. So I want to introduce Bob Laird, who's going to be our keynote speaker, and Bob's going to be sharing thoughts on mathematical proficiency for all students. Bob has been done a lot of things in the state of Vermont around math education, and those include working with the All Learners Network on facilitating middle school cohorts, as well as helping edit current book chapters that are being put out, and just a general all-around advisor. When he's not doing that, he's working for the Vermont Mathematics Initiative, where he really helps lead the teaching learning. If anyone here is a VMI participant, no doubt Bob read your action research and provided comments back and forth for you. He's also helping the Vermont Mathematics Initiative develop new programs currently that are in process. Some of you may know him from his work with OGAP, the Ongoing Assessment Project, where Bob is one of the, I don't want to say founding members, that sounds so high, but certainly one of the people who was there from the start and has helped author several of the books, a focus on fractions, a focus on multiplication, division, and most recently a focus on ratios and proportions. I've had the great pleasure of working with Bob on a number of projects and in a number of capacities, and I can tell you that every time I get a chance to talk with him or listen to him, I learn new things. And, you know, while Bob may have traveled the country and the world in his capacity with OGAP and other organizations, and he's been sharing his knowledge and working with people to continue to improve math education, it is the teachers and students of Vermont that he keeps at the heart of all of his work. So without further ado, I'm going to hand it over to Bob. And if you have a question during the keynote, feel free to put it in the chat box, and I will, at appropriate time, share that with Bob. So welcome, Bob.
So thanks, Fran, and welcome, everybody. I want to, first of all, just thank everybody for being here. And for really embracing a project that is really groundbreaking in some ways. I think back to last year when we were all in Killington face-to-face, sort of the excitement in that room. And I'm really hoping we were able to kind of continue that excitement here today. I know there's some great breakouts sessions coming up, and it just feels like a great day to not only learn, but sort of celebrate what it means to be a math teacher in Vermont and in Maine and maybe other places, and to really dedicate a few hours to thinking about all students. So I just want to start out by saying that the things that I presently am thinking about in terms of mathematics is mathematics as instructional reform. In other words, you know, I cherish watching you teach, and individual teachers, but really the challenge ahead of us and in front of us is around instructional reform across the system. And sometimes researchers call those kind of things ambitious instructional reforms, of which the All Learners Network is one of those things. And the issue, this issue of ensuring mathematical proficiency for all students is certainly an ambitious reform, and something that, as far as I know, has never been attempted anywhere. So I welcome you into that challenge. So what I often think about with reforms is what is it going to take for a reform to actually work, and then what are the pitfalls in those kind of reforms? You probably know, if you look at the history of educational reform in this country, that it's filled with a lot of great ideas and, unfortunately, a lot of failures for those ideas to reach scale. But what I want to try to do today is cast the work that you're all up to individually, and that ALN is up to individually, and some of those important details, all those things that we think about, I want to cast them into some larger themes, because I think one of the things I see in educational reform, one of the sort of pitfalls, is that the focus becomes on details, which are definitely important. Instructional day-to-day details, or details about the day-to-day things going on in school systems, and we forget to focus on what are those big themes across that reform. So today, I really am thinking about today as an intended to just share some thoughts in those areas about transcending themes in terms of mathematical proficiency for all students. And I'd like it to just spawn conversation, hopefully across today in your breakouts, but also when you get back to your schools and work with your colleagues and work with your students. I'm going to really focus what I share with you today on mathematics primarily, and all the time acknowledging that there are other really important parts of this story, such as, gender, race, language, culture, and also that specialized knowledge it takes to work with certain students with severe needs in mathematics. I understand all of those are part of the story, but today I really want to focus on mathematics primarily. But I do think that some of the things we'll talk about today really have implications for all of those other issues. So the first thing I want to start out with is I want us to rethink the term achievement gap into two other ideas. I'd like us to think about it as an instructional gap and an opportunity gap. And I think the reason those are important is because it puts the power of change into the adults working with students. So when we talk about an instructional gap, that's something we can do as a community of math teachers. When we talk about an opportunity gap, that's something we can actually act on. When we talk about the achievement gap, it sounds like what we're talking about is something that's about the student. The student isn't achieving, Bob isn't learning. But I think that thinking about it as an instructional gap and an opportunity gap allows us to really take ownership and do something about that. So I just want to start that out. That's not new. Those are ideas that have been floating around in our domain for quite a long time. I also just want to start out by saying where I think mathematical proficiency lies. So I think mathematical proficiency lies in an intersection between math teachers which I'm going to use for a proxy for instruction that every kid gets every day, and the systems that support that instruction. And I believe that mathematics proficiency for all students is going to lie there. So if we think about instructional reform here, we're thinking not only about individual teacher instruction, but we're also thinking about the systems in which that instruction occurs. So I know from being out and about in a bunch of places that the systems can support great math teaching, or they can actually hinder it. And math teachers can support instructional reform at a system level, or they can actually repel it. So in the best of worlds, we would have a system and math teachers that are supporting each other in our move towards mathematical proficiency for all students. So today, as we talk about things, sometimes it's more focused on the math teacher and the instruction, and sometimes it's more focused on the system in which they work. And I'll just move back and forth with those sort of seamlessly. But that's how I sort of think about it. And when I think about systems, I'm thinking about things like, things like your grade level team, or your math department, your school, maybe the math program you use is systematic. The assessments you use, those are all part of the system. And in some ways, we can influence that system as math teachers, and sometimes we can't. But so I just want us to sort of think about those. And I really then want to start off by considering some instructional needs of a student. And so I want us to think about some learning descriptors around students in our schools and in our classrooms. And as we think about those and we move from the left to the right, what we're seeing is increasing levels of struggle for a student, starting with students that are highly successful in math. And you'll see that the struggle increases as you move to the right, to the point where we have students with years of misconceptions that actually impact participation in math class. And so if you look across those, the first thing I like to do is imagine a student that I've had who fits into those descriptors. Now, this isn't the whole story, but I just wanted you to get a sense that kids that we have in our classes every day have different learning needs based on what those descriptors are. The other thing I like to think about is a student, and I have a student in mind who started their schooling experience being successful in math. And as the year and the years progressed, the students' needs moved from left to right. The struggles began. There was more struggles until the point where the student was really impacted in their participation each day. And I'd like you in your head to have an anchor of a student who, as their experience moved, started to increase in their struggle in mathematics. So I also just want to add a caveat that I know that there are many students, or a number of students, that enter our schools already years behind with misconceptions. And I understand that we have a segment of population of our students for whom that is going to be the reality. But I also want to make the case, I want to make a couple cases here with these learning descriptors. The first thing is that the instruction these students need in these various descriptors are going to be different. The second thing I want to make a case for is that as students' needs move from left to right, their experiences are moving from instruction based on the teacher they love and the peers that they're comfortable with to instruction in different settings. So as they move to the far right, we suddenly have changes in schedules. We have specialized materials needed. We need budget considerations. And maybe the most important, we need buy-in from students who are experiencing a change in what they've expected school to be into being something else. So I'm going to make the case that we need to think long and hard about ways to prevent student instructional needs from moving outside of the classroom. And again, I understand that for some students, that is exactly what has to happen because of their needs. For other students, I think that many of us believe that in the classroom with the teacher and with their peers is the best place for their learning to happen. And as the students' needs move from left to right, they carry with it some consequences as they move out of the classroom setting. So I just want to leave that idea with you. And in fact, I'd like us to think about the fact that education is a nurturer, as evidenced by over 100 of you here today who nurture students every day. But it also, over the history of education in our country, it also winnows. So I often think about this image where all students start school, and by the time they end school, we have some students that have received the that have gained the mathematical knowledge that's needed, that we believe is needed to be successful in further education and also daily life and employment. And in fact, in a great book called Grasp, written by Sanjay Sarma, he talks about this winnowing effect on education. And so I want us to think about that we've got this shape of math instruction that looks trapezoidal. And what I'm going to challenge you here today to think about is how we would recalibrate the shape of that educational system to be rectangular instead of trapezoidal. In other words, we're going to start with all students. And by the time we get to 12th grade, graduation from high school, we have all students that have attained mathematical proficiency, and we haven't winnowed. And as we think about that student that I asked you to keep in your head earlier when we thought of learning descriptors, as that student's needs move from left to right, there's the possibility that we're already putting into play this winnowing effect. We're changing their schedule. They're perhaps missing art class or recess or what other kids in the class are doing because we are, through our great intentions and our moral imperatives, are trying to give them the math instruction they need. So we have to understand that the winnower is sometimes things that happen through instruction, and other times they're systematic. And I could certainly end here and just challenge you as you're talking with colleagues, and as you're talking with colleagues and you're talking with school leadership and other teachers, what are the winnowing moments in a student's educational experience that changes, that makes the shape of our system trapezoidal instead of rectangular? And so what I'd like to do is just offer some potential winnowing moments in students' math experiences. And I'm trying to keep students right in the forefront here. I'm trying to imagine, I'm going to try to put myself in the place of students who are experiencing some of the moments in which they start experiencing the winnowing effect. And in fact, there's some research to suggest that as kids start to move to the edges of mathematics and ultimately decide that mathematics isn't for them, happens potentially really early and can can happen potentially really early in students' careers. So this is something I think we have to be aware of from the very earliest days when kids enter school. So the first thing I want to just talk about is sort of a winnowing moment is how we speak about our students. And I know that we have teachers that have talked about this a lot. And as we look to sort of the list on the left, there are certain labels that we give kids. And I wrote down some things that I hear fairly regularly. And those are fairly obvious labels. But we also talk about students in other ways, in ways around what they can't do. And I think it's more, and those also put kids into categories. As soon as we say somebody can't do something, we've suddenly made this binary decision that there's some kids that can and there's some kids that can't. When actually we don't know what kids can and can't do. All we know is that they didn't. And we'll revisit that idea when we talk about assessment. So what we know is a student didn't particularly show evidence of being able, didn't show evidence of dividing, or we know that a student didn't finish their homework, but we didn't know if they could. And those words make a very big impression. And when we talk about students like that, we're impacting our own belief in students, and we're also communicating to students that there are some that go to the left and some that go to the right. And those can be winnowing episodes. The second idea I want to share with is this idea of, well, first of all, before I go there, I want to just kind of give a little bit of research credence to some of the ideas I'm going to share with you today. And there's many things I could have shared with you research-wise, but I'm going to sort of hang with, for a few moments with some of the John Hattie work from 2017. And I just want to give you a little background to this so that you can sort of understand a little bit of the research that I'm going to share with you. So over the decades, Hattie has looked at 150 influences on learning. What he's been able to do is take an attempt at estimating how effective various things we do with students are in schools. And not only things we do in schools, but things inherent in their communities and things inherent in their families and all. And he calculates what we call an effect size. And without getting into too much detail about an effect size, it's really a measure of how effective something is in impacting an outcome. The average effect of a learning influence in school is about 0.4. So if I give you a number that's 0.2, you know that that's far less than average. If you see something that's 0.8, that's twice as effective as average. And also what Hattie did was rank those learning influences from 1 to 150. So number 1 would be the most effective learning influence that he studied, and 150 would be the least effective, the one you'd probably want to stay away from. And like all research, I'm going to ask you to just use these as estimations, not necessarily the truth. But there's something we can use as a way of at least putting into some sort of proportion the effectiveness of things that we do with students. So in this particular case, in terms of labeling students, in a list of 150 learning influence, Hattie ranked that as 25th if we stopped labeling students tomorrow. That has an effect size of about 0.6, you can see, which is far above average. So the idea of labeling students is not only about preventing the winnowing effect, but it's also about learning. The next thing I want to just share with you is this idea about groupings. And you can see again some of the research from John Hattie. It's really interesting to me that when we study groupings, they're not generally incredibly effective compared to some other things we could have done. I'm not saying we should never group kids. I'm not saying that at all. what I am saying is that when we group, there is a potential that we are grouping again by who can do something and who we perceive can do something and who we perceive can't do something. And that we're communicating to kids that some kids can do math and some kids can't do math. And we're pushing them to the edges of that trapezoid. Notice even that the impact, Hattie found the impact of grouping for gifted students, not all that effective as well, even though sometimes that's some of the impetus for grouping is that we want to make sure we're not holding successful students back. So, so again, I just ask us to think about grouping. I'm not saying we shouldn't do it. I'm just saying we have to be aware of it. However, if we thought about rather less about grouping and more about what we believe happens effectively in small groups, we start to see much, much higher impacts. So if we thought about it as cooperative learning, which is probably going to happen in a small group of students, we see that cooperative learning actually has a pretty high effect and it is pretty high rank. And the same with classroom discussion. So if we can focus our intentions on ensuring cooperation in learning and discussion in learning, those seem to be more important and more effective and less of a winnowing effect than putting kids in groups, particularly groups that are long-lasting groups. The next sort of winnowing ideas I just want to leave with you are going to be related to this idea of mathematics as calculation. Unfortunately, we still, and I'm using we here, not you and not me, but we as in the sort of the collective we in mathematics education, across our country. So unfortunately, we inaccurately communicate to kids. We too often inaccurately communicate to kids that mathematics is calculation. Yet we know that mathematics is more than calculation. In fact, calculation is about 1/5 of what we believe mathematical proficiency is. So I use the term mathematical proficiency, which came from the 2099 Adding It Up, which I highly recommend all of you get a free electronic version and use that in your work with your colleagues, particularly chapter 4, which does a really good job of the best job that I know of in describing what it means to be mathematically proficient. And for some reason, however, over the years, the procedure and the calculation has gotten an oversized voice in the way we think about which kids are good in math and which kids are not good in math. And there's a few things that I think are related to that, which also contribute to this winnowing effect. The first is mathematical prerequisites. And again, I want us to think about this not through the lens of we should never have a prerequisite for anything in mathematics, but I want us to really go in with our eyes wide open about what are those mathematical prerequisites, and are those actually there, and do they actually serve to winnow kids away from fun, demanding, real, engaging, appropriate grade level mathematics. So examples of those could be, I'm holding kids back from exploring fractions because they don't know their math facts, or keeping kids from algebra because they didn't pass or get a high enough score on a placement test. So I'm going to be the first one to tell you, I'm not the first one to tell you, I believe strongly that there are really important buckets of prior knowledge that are essential for learning new mathematics content. But I also know that we often put up barriers that are we use as prerequisites. And again, the we might be the system, it might be me, Bob, as a teacher, that keep kids from experiencing the grade level mathematics that we think are so important. There's actually a number of university professors, admittedly sort of the small fringe, who are really rethinking this idea of prerequisites if we're thinking about all kids having opportunities to learn important mathematics. And so I'm just going to throw that out to you to really think about and talk about. Also connected with this idea of mathematics as calculation is our over-reliance on a test score as the true measure of student knowledge. You know, if we had a lot of time, I think a discussion with all folks, but particularly those of us that are really thinking deeply about mathematics for all students, is we've got to really talk about assessment. And if we go back to this idea as mathematics as calculation, I want you to think about the assessments that you use in your classroom or in your school, whether it's progress monitoring or quarterly assessments or whatever it is that we use in our classroom. And my experience is that most of those assessments are primarily assessments around calculation. So it's very possible that when a student does really well on a typical assessment, what they've shown you is that they were really quick and accurate in the calculation. And thus, in some cases, we say there's a student that knows their mathematics. Student who didn't do really well on that wasn't fast and wasn't accurate in their calculation. And we have a tendency to think that's a student that's really struggling in math. And that very well may be the case in both of those instances. Yet we've used calculation as the gateway to determining success in mathematics. And that's even in a day when, if you look above of the 5 strands of mathematical proficiency, calculation and procedures is the only one of those 5 that we could solve quickly with the push of a button on a cell phone or a calculator. And I'm not saying that there isn't a role of calculation, because there is. We learn a lot of important things in mathematics by doing calculations, and they should not go away. Yet, again, I'm going to say that in many times in our assessment, they just have they just get a very large voice, and we might want to think about how do we give voices as well to the other parts of what it means to mathematically be proficient, and would that be a truer measure of what students are understanding in mathematics? I want us to think, it's sort of, if we were thinking of assessment in mathematics 101, I want us to take to heart that a test score is always an estimate of what a person knows and can do. It's always an estimate. Sometimes it's a really good estimate, and sometimes it's not such a good estimate, but it's always an estimate. And so we have to use that and talk about that with students, with parents, and with colleagues as an estimate. We always have to hedge our bets on a test score. And we have to know that if I had used a different assessment instead of the one I used, that the student score would probably be different from the assessment I chose to use. It might be hugely different. It might be small differences, but it will be different. So again, I'm going to say we always hedge our bets. And if we think about that student, I asked you to keep in your head earlier, we should always be very, very careful to make a decision that's going to change that student's day-to-day experiences in mathematics based on one test score. We want to, you know, if we're going to make a change in a student's schedule, if we're going to take them out of something, if we're going to say sort of remove them from the classroom, remove them from their peers, we want to do it because we know that it's the best thing for learning, and we're doing it based on information that I'm fairly confident to be more true than not. And a single test score, I think, is just really dangerous to make that kind of consideration. So those are the sort of the some of the winnowing things that I've been thinking about recently. I know there's a lot more, and as I said earlier, I know there's a lot that deals with race and with native languages and with culture that we could add to that list, and I invite you to do that. But I wanted to share these with you just so it gets the conversation going. Got just a few other things. There's just a few minutes left, and just a few other things I'd like to share with you before we wrap up. And the first, again, is just a little bit about assessment. One of the things we think about with assessment is how sensitive are different assessments to learning? How close are they to the actual act of teachers teaching and students learning? And over again, what we find is that embedded formative assessment is the most sensitive to the experience of student learning. And as we move away from that, and you can just look at the other examples of different assessments we do, we get less and less sensitive to learning. So when formative assessment hit the airwaves, 10 or 15 years ago, as it should, suddenly I would go to districts and schools and every assessment they were giving was formative, which is just not true. There is something very particular and very special about formative assessment and why it's so sensitive to learning. And I just want to share a little of that with you now. So the first thing is that if we want the gains from formative assessment that the research suggests are possible, formative assessment is first and foremost as students are learning, not after they should have learned. So we're thinking about formative assessment at the moment, such that a teacher can use that to give students the just right instruction they need. It's far less effective. That information is far less effective the farther away you move from the moment of learning. So that's one way we think about effective formative assessment. The second thing I think about with formative assessment is it's for the teacher and her students, and that's it. So as soon as we start recording those, giving them scores, giving them numbers, sharing those at a school-wide basis, we've lost a lot of the power of formative assessment, because pure formative assessment lies in the interaction between the teacher and the student only. The student is giving you information. You are in turn becoming a better, more targeted teacher with the information you've gotten from those students. The other thing I'd like to say is how we use formative assessment information it's not a score, it's information. And Dylan William, who's really the father of modern formative assessment, talks about that information as minute by minute and day by day. And so the idea is that we as teachers would be, our instruction would be highly influenced by the information students are giving us. And then we ask kids to engage in monitoring their own learning and their own actions based on that information. One of the things I think we found over the years is that the most effective intervention with students is the intervention that happens right at the moment of learning. Thus, I think about first wave instruction as the first and most powerful place for intervention to happen. It's the thing that's going to keep our student from earlier in this session from learning needs moving far to the right. I want to know instantly, minute by minute, day by day, what's going on so that I can be a better teacher right off the bat. The more we let those ideas fester and those struggle in the class, the more chances of being winnowed and the more chances that those students' needs are moving farther to the right, as we saw earlier. If we look back on, I could give you so much research about the impact of formative assessment from so many different sources, but I'll stay with the theme of John Hattie. You can see that three essential features of formative assessment are incredibly highly ranked with very impressive effect sizes. So if we could say one thing that we could do tomorrow that could, I think, really impact the winnowing and really help all students learn, it's got to be embedded formative assessment. And if you don't like the A word, we can think about this as formative instruction. And it's, again, just highly, highly sensitive to learning. And for our kids that struggle, it's not an add-on. I'm going to make the case that it is necessary. I want to give just a little example for this, and for this I'm going to take some student work that I thank the ongoing assessment project for. I want to show you 3 different examples of student responses to multiplication problems. And the first one is John, who's trying to figure out how many wheels on 29 tricycles. God bless John. John drew 29 tricycles, drew every wheel with the handlebars fully intact. And if you could see this closer, you could see that there's a pencil dot, which suggests that the student counted the wheels and got to 87, which is the correct answer. Sandy, on the other hand, was trying to determine how many pictures in this array, and Sandy has evidence of skip counting. We look at Chris. Chris is trying to figure out how many eggs in 7 dozen. Chris actually applied a property of mathematics, applied the distributive property, and got to 86. Well, 86 is not the correct answer, by the way, because 7 times 2 is not 16. But the point I want to make 2 points with this student, with these examples of student work in terms of sensitivity to learning. The first is that if these represent what students are understanding, and that's a stretch because it's dangerous to do this on one piece of student work, but let's imagine that these represent what students are thinking. Each one of these students requires something a little bit different in terms of instruction. We might want to help John start thinking about grouping more. Could John start to do what Sandy did? Could we count by 3s? With Sandy, we'd want to think about something maybe around area. Could we start thinking of moving her knowledge from skip counting to maybe rows and columns? If I know the number of rows and I know the number of columns, could I use that to determine how many pictures? We could argue that the students based on this information that might have a more sophisticated understanding of multiplication is Chris, who applied a relatively abstract response. Yet, if this was a summative assessment and these were in the domain of multiplication, notice that John would get it correct and he would get a point or points in the multiplication column. Sandy would get a point in the multiplication problem, and Chris would get it incorrect. So there's an example that if we thought about these as summative questions, those are very less sensitive to the teaching learning process than if we think about these as being formative. The last thing I think I'll ask, it's getting close here, is I just want to add something a little bit about standards in teaching here. The first is that there's always this debate: is it content? Is it teaching? And I just want to give you both ends of this sort of discussion in our profession. One of them is about who sees that the standards are about content. It's not about teaching. And then if we look at Dylan William, who's far to the other side. And I think that what that would tell us is that in most things where there's disagreement on the far ends of the spectrum, we probably could say that content matters, and so does great teaching. And that what the success for all kids and the ability to keep kids engaged in mathematics and avoid winnowing is a combination of the content, and it's a combination of the instruction. But what I want to make the case about the Common Core right at the moment, or the structure of math standards, is that it's not about the individual standards, which we often perseverate over. If we look at an individual standard in any standard, take multiplying two-digit numbers in 4th grade, that content is not that different than standards we've used for years and years and years. We've wanted kids to multiply two-digit numbers somewhere around 3rd or 4th or 5th grade or something like that. I will argue that the second part of most standards in the Common Core are different, because they often allude to how we want kids to be able to do that. So the idea that we want them to multiply two-digit numbers using models or properties of operations or estimation is new and good. But in general, the standards themselves are not that different. But what is different is the structure of those math standards. And as teachers and administrators and decision makers, this is the most important part of math standards. It was written about eloquently in the very beginning pages of the Common Core, yet it doesn't find its way, in my opinion, into the day-to-day work of teachers. So the first of the triads of structures that the Common Core paid attention to was the idea of focus, which is spending more instructional time on fewer topics, so that those things that we do focus on get learned and taught more deeply, in a more excited way, in a more interesting way. If we truly have focus in our standards, it allows instruction to do two of the most important things in learning for all students. The first is treating mathematics as an equal opportunity for concepts, procedures, and meaningful problem solving. So if we think about our own instruction over the course of a week or a month, could we see these as a third, and a third? That would be one major thing we could do for all students, is to refocus mathematics into its proper proportions. The second thing is that the math standards is about this idea that math makes logical sense, and they're logically connected. There's a small number of ideas, and those ideas play out over and over again across the grades. It's what allows great teaching to build on prior pre-existing knowledge. So rigor and coherence are things that we could do tomorrow, even though I'm going to make the case many of our materials don't do this that well. But our goal ought to be spending more time on fewer things, addressing mathematics and communicating mathematics to kids as an equal opportunity to do to work on concepts and problems as well as calculation, and then to form the basis of our instruction on building on pre-existing knowledge. So I think I'm going to sort of leave that there. There's going to be I'll post these slides. There's a few other things that I'm going to skip over right now because I know the time is short. And I'm just going to kind of fast forward to just a little bit of a closure. So what I'd like to propose to you is I'm going to propose that our goal going forward, if we're to think about what's our primary mission, I think it's changing the shape of mathematics from a trapezoid to a rectangle. And in order to do that, I'm going to invite you to think about how our systems do certain things and what's the impact of that in changing the shape. So we talked a little bit about how we talk about students. A little bit of thinking about how we group and why we group, and the precautions that we might think about that. I'd like us to consider the prerequisites we have either in our day-to-day instruction or in our systems. I'd like us to think about redefining mathematics in a much more accurate way. And I'd like us to think about the assessments we use to improve instruction as students are learning, and rather than as a summative way, assessments that's really sensitive to the teaching and learning. Ultimately, I do believe that we are not looking at an achievement gap so much as we're looking at an opportunity and an instructional gap. And I think all of us going forward, I'm going to ask you to dedicate ourselves to thinking about what excellent instruction for all students looks like. And I know from experience and from talking with students who've struggled and teachers that the number one thing that keeps kids from being winnowed out is thoughtful, talented, and loving adults working with them in mathematics. And I'm going to stop there. I just want to thank you. I want to welcome you to the day. If you have questions, feel free to drop me an email. I'll post this online, and just have a great day. I'm going to sort of turn this back to Fran.
Yeah, huge thank you to Bob for his talk today. Thank you, Bob. That was, as usual, yeah, you're getting a lot of hands up and clapping symbols, etc. As usual, Bob, you've given us a lot to think about. I just wanted 2 quick details with everybody here. And I'm going to share my screen with you. Okay. One is the get in touch. If you want to know how to get in touch with the All Learners Network, you can go to the website, and there are a lot of different things on there that the All Learners Network offers, from online courses, menu subscriptions, free lessons, high leverage concepts. We have practice notes, blog, and community discussion. And then all of you should have received a in your email. To get to this, you received this, and if you click on these join buttons, that's how you get to your next sessions. I want you to know that in session 3, the developing classroom discourse session that will be led by Mike Stevens is targeted at grades 5 to 9. So just make sure that you note that. Otherwise, we will see you at you have a break now, and we'll see you at 10:15 at the next session. So thank you all for taking the time this morning to join us for the keynote, and we look forward to spending the rest of the day with you.